Dear students, welcome to first PU physics class. In this class, let's start new chapter Laws of Motion. In this chapter, we will discuss motion of a body by considering cause, that is force. In our day-to-day life, we observe that body is at rest, remains at rest unless someone pulls it or pushes it. Some push or pull is needed to set a body in motion. Similarly, if a body is moving, then again some push or pull is needed to stop motion of the body. Hence, force is required to stop a moving body or to change direction of moving body or to change state of rest. Next, inertia. Inertia means opposed to change. In Kannada, jadatva. It is inherent property of the body in which it does not change state of rest or state of uniform motion by itself unless it is compelled by an external force. Okay? Means when net force acting on a body is zero, the body is at rest, continues to remain at rest, and body in motion continues to move with the uniform velocity. Okay, here the inertia is the opposition offered by the body to change state of rest or state of uniform motion unless some external force acts on it. There are three types in inertia. First one, inertia at rest. Second one, inertia of motion. And third one, inertia of direction. Let us discuss one by one. Inertia at rest. It is inherent property of the body to remain in state of rest unless external force acts on it. Okay, we know the bodies is at rest, remain at rest unless external force is applied to them. Means the body cannot move itself from state of rest. It requires force. Okay. Example, book is on the table, continues to be at rest. Okay, the initially book is at rest. Now same state is continued. Suppose book is displaced when it pushes with some force. Okay. Next, second one, inertia of motion. It is inherent property of the body to continue in state of uniform motion unless external force acts on it. Okay, here the body is in uniform motion is continued unless the force is applied to it. Example, swirling of milk in a glass continues even after stirring is stopped. Okay. Next, third one, inertia of direction. It is inherent property of the body of which it is unable to change direction of motion unless external force acts on it. Means a body is moving in particular direction can never change its direction by itself unless a force is applied on it. Example, when passenger travels in a bus, when bus changes its direction, then body of passenger lean to opposite side of direction. Means direction of lean of passenger is not changed even though direction of bus is changed. Okay. Next, Newton's first law of motion. Statement as follows. Every body continues to remain in its state of rest or uniform motion along a straight line unless it is compelled by an external force. Means if net external force is 0, a body is at rest, continues to be at rest, and body is in motion, continues to move with constant velocity. Okay. Means if external force is 0, then body does not change its state. So whether it is state of rest or state of uniform motion. So this law gives definition of force. Force is external agency required to change state of rest or state of motion of a body. And also this Newton's first law is called law of inertia, because statement of Newton's first law and definition of inertia are same. Okay, hence Newton's first law is called law of inertia. Here the examples for Newton's first law are similar to examples for inertia. Okay. Next, inertial frames of reference and non-inertial frames of reference. First, the inertial frames of reference. The frame of reference in which Newton's first law is valid is called inertial frame of reference. Here the frame of reference means coordinate system. Okay. Here the coordinate system in which Newton's first law is valid or satisfied, such frames are called as inertial frame of reference. All frames of reference moving with constant velocity with respect to an inertial frame are inertial frames of reference. Okay, in this coordinate system, the object moving with the uniform velocity. Okay. Next, non-inertial frame of reference. The frame of reference in which Newton's first law of motion is not valid is called non-inertial frame of reference. All frames of reference moving with acceleration with respect to an inertial frame are called non-inertial frame of reference. In non-inertial frames of reference, velocity is not uniform. Okay. So in this coordinate system, the object moves with variable velocity or the object moves with acceleration. Okay. Such frames are called as non-inertial frames. In non-inertial frame, apart from force applied on the body, an additional force appears to act on the body. This additional imaginary force on the body is called fictitious force or pseudo force. Okay. It appears due to the acceleration of frame of reference. Okay. Example, when lift is moving downwards with an acceleration, the weight of a person appears to be smaller than actual weight. Whereas